Section 5.3, the definite integral. Um, so if you want to find out integration of any function f of x where your variable is x, this is the notation we are going to use for integration. But if it's a definite integral, it means you want to find out this integration from one fixed point to another fixed point. So this is the notation for definite integration. The function is the integrand. This is the function. X is the variable, and we want to find out the integration from one point to another point, from a to b. This a is called lower limit of integration. This symbol is called integral sign, and b is upper limit of integration. Okay, and how do we find this? We use Riemann sum for finding the definite integration. We already know what is Riemann sum from previous section. So let's say there is a function f of x which is defined on interval a to b, where we would like to find out this definite integral. For that, we divide this ab into different partition. Okay, and then that is called partition p. So on each partition, on each subinterval, we can pick a point of our choice, like left point, right point, or midpoint. That's up to us. And we can find out the value of the function at that point, the multiplication of the value of the function. This is the value of the function at point ck. And this del xk, that means, for example, let's say this is your xk minus 1 and this is xk. Del xk means width of this subinterval. So this is called Riemann sum. Now the definite integral is actually this Riemann sum, and this is how we define it. As you can see here, given any number, positive number epsilon, there is a corresponding positive number delta, such that for every partition, no matter how you take this partition, so in this case, let's say x0, x1, and then up to xn minus 1, and this is xn. So let's say this is partition x1, xn. So this is partition of this interval a to b. No matter which partition you pick, if the num of this partition, this is called num means the largest subinterval, length of the largest subinterval is less than delta. In that case, the Riemann sum is equal to that definite integral. So basically, for finding the definite integral of function f of x, you have to find out the limit of the Riemann sum. Okay, and that is that is our definition for the definite integral. This is the limit actually. So now, if while taking that partition of this interval ab, if we take that subinterval of equal width, a formula for Riemann sum with equal width subinterval would be look like this. Okay, so here what is happening is, here in this case, the length of this subinterval, this del xk, depends on which subinterval you are talking. So this length varies, but if you are talking about equal width subinterval, then this definite integral is equal to this limit of the Riemann sum. You just have to plug the value of ab and then k, and find out the sum and then limit of that sum. That's how you find a definite integral. If your function is continuous or has a finite discontinuity, jump discontinuity, then that function is integrable. That function is called integrable, and in that case you will be able to find out this definite integral. So the only if function is continuous, then we should be able to find out this definite integral. Or even we have, let's say, a finite number of discontinuity. Okay, finite number of discontinuity. For example, this is one function which has 1, 2, 3 discontinuous point, and then that's a finite. If you have a function with finitely many jump discontinuities, finite only, then still you can find out the integration of this kind of function. So Keep in mind, integration, this definite integral is only possible if function is continuous or has a finitely many jump discontinuities. So let's assume that f and g are two integrable functions, meaning we can find out the integration of f and integration of g finite from a to b. Then these are the some rules we can use. The first one is if you're trying to find out the integration from b to a, and then if you try to switch that limit of integration, then there will be, you have to put negative sign. So switching is fine, but one would be positive and one would be negative. Okay. The second rule is if you are trying to find out the integration from one specific point to the same point, then that would be 0. The integration would be 0. Constant multiplication, you have a definite integration and there is a constant inside that integration sign, then you can bring that constant outside. Sum and difference means sum of integration of sum of the function or difference of the function is same as sum or difference of integration of the function. If we would like to add this limit of integration for the same function, let's say here you can see that this is definite integral from a to b, and this is also definite integral starting from b to c. So this final point and this initial point, they are same. So instead of doing that, we can just say that okay, this is the integration from a to c directly. Maximum and minimum inequality. Let's say f has a maximum value and then minimum value, then the integration of that function from a to b is always greater or equal to minimum value of that function times b minus a. B minus a means it's a difference between a and b, and then less or equal to maximum value of that function times again b minus a. So this definite integration of a function from a to b is bounded by a product of minimum of that minimum value of that function times b minus a from the lower bound, and from the upper bound it's the maximum value of that function times b minus a. Okay, if a function f of x is greater or equal to function g of x, then that means the definite integral of the function f of x should be greater or equal to the function definite integral of function g of x from a to b. Okay, if the function is positive, then definite integral is always non-negative. These are some geometrical interpretation of the rule from 2 to 7. So here are the rules and these are the geometrical interpretation. For example, for 2, this is integration of f from a to a. That means that is 0 actually, because the width of that is 0. This is integration of k times f of x. In this case k is 2, so basically it's the integration of f of x, and integration of 2 times f of x is actually, you can just multiply the integration of f of x by 2 and you will get the same result. So these are just geometrical interpretation of the rules we have here. Now if we are dealing with a positive function, let's say function is non-negative, which means it's above the x-axis. If we have non-negative function, this is the function for example, then definite integration of that function from point a to point b is actually the definite integration of that function from point a to point b. Actually it is a area of the curve, area of this curve, area of this region under this curve and above the x-axis. So if f of x is non-negative integrable over a closed interval from a to b, then the area under the curve over ab is actually that definite integration. So definite integral is very useful for finding the area under the curve if that function is non-negative. If it's negative, then that would be negative of the area. If this function is negative, then this definite integral is actually negative of the area. For example, what I'm trying to say is, let's say this is the curve from a to b, then integration of that function f of x from a to b is negative of this area. But basically this definite integral will help you to find out the area under the curve. And we can also find average value of the function, that integrable function on interval AB, by using this definite integral, which is basically 1 over b minus a times the definite integral. That will help us to find the average value of the function, which is also called mean. So now let's see a couple of examples. Express the limit as definite integral. So this is the sum of, this is the Riemann sum. From here we can see the function we are using. This del xk means it's a this is just a width of each partition, and this is our function. So our function is starting from 1 to n, and it's going from -6 to 2. So this interval gives us the value of a and b. So this is basically from a to b f of x dx. So the function f of x, first of all, the range a to b comes from this interval, which is -6 to +2. This function is coming from whatever you have here right before this del xk. So which is basically 4 times ck. Ck means it depends on let's say you have from -6 to +2, and you are just dividing this into different subinterval, and one of the subinterval is xk minus 1 to xk. Here you have the point ck, okay, and this is actually the value of the function at that ck. So the value of the function at ck is 4 times ck to the power 7. So by looking this particular value, we can find out the value of the function. If you replace this ck by x, that will be 4 times x to the power 7. So that's why the definite integral for this Riemann sum is actually from -6 to 2, 4 times x to the power 7 dx, and this del xk can be replaced by dx. Okay, that's all. And how do you find this value? We're going to see more examples and we will be able to find out this one later. Okay, not here, not in this section, particularly for this particular example. Okay, so now we know from previous information here, if you want to find out the Riemann sum, and if you want to find out the definite integral with the Riemann sum with equal width subinterval, then this is the formula we have to use. So this is where we are going to use that. So this is the formula we have given. So just find out a, which is -1, b, which is 0, and n is not known. So for finding this definite integral, we need to find out the limit of k equal 1 to n. Just plug the value of a, which is 0. No, a is, yes, a is -1. A is -1 plus k times b minus a. B minus a means it's a 1 over n times b minus a, which is 0 minus -1, which is 1 over n. So this is the formula, which is sum of k equal 1 to n f. This is k over n minus 1 times 1 over n. But what is the function here? What function we have given? F of x is 5x minus 4x squared. So we need to find out the value of this f of x by replacing this x by k over n minus 1. Look at here, k times 1 is k over n, and there is a minus 1. So what is the value of this function at k over n minus 1? Just replace this x by this value, which is 5 times k over n minus 1 times 4 times k over n minus 1 whole square. So this is the value we're going to use here. So k equal 1 to n. This is the value of the function, which is 5 times k over n, right? K over n minus, distribute this 5, which is 5, and then there is a k over n minus 1 whole square minus 4. K over n minus whole square is k square over n square minus 2 times k over n plus 1, and then there is a 1 over n. So we need to find out this sum. So let's simplify this. I need to insert one more blank page here to work further, and then let's simplify this. Okay, so our goal is to find out the sum of this, and then after finding the sum we need to find out the limit. So for that we need to know some of the formula, so which I'm going to give you. So we plug the value of f of this thing, which is coming from here, 5 times this, and then 4 times the square of this. So square of this is k square over n square minus 2 times k over n plus 1. Okay, after that let's see what happens here. Let's go to the next step here. I'm going to multiply this everything by 1 over n, and I'm going to expand this. Okay, so the next step is k equal 1 to n, and we need to find out the limit of that. So there should be limit sign, limit when n goes to infinity. So if I multiply everything by 1 over n and then distribute, if I multiply every single term by 1 over n and distribute this 4 here, this is what I'm going to get: 5 times k over n square minus 5 over n minus 4 over n cube k square plus 8 over n square. Use the multiply by the negative sign, makes it positive, minus 4 over n. So now this is 4 over n. Now we have to combine the like terms and then try to simplify it. We have to combine the like terms and try to simplify this. Okay, so 4 over n, and then this sign, this summation sign is for every single term. If you combine the like terms here, you'll be able to see the first term and then the second term from the last is they are same, they are like terms. So 5k over n square, 8k over n square, so that will eventually gives us 13k n square. We can combine this negative 5 over n and negative 4 over n, which is negative 9 over n, right? And then after that there is a leftover, which is negative 4 over n cube k square. Remember, before finding this limit we need to find the sum, but for this sum the only thing is running is k. For this sum n is constant, so you don't have to worry about n while finding the summation sign, because look at here, what you are replacing here: k equal 1, k equal 2, k equal 3, and you just keep summing it. So for the summation, this n is constant. So when you try to find out the sum, I can keep this constant thing and then n outside, and I just have to find out sum of the terms of wherever we have this k. For the second term there is no k, so that is actually sum of 1. I can write it down like sum of 1 from k equal 1 to n, and then eventually this is, I can keep this 4 over n cube outside and then find the sum of k square. Okay, because when you try to find out this sum, this n behaves like a constant. Okay, so now what is the sum of the first n natural number? This is the formula we have. This is equal to n times n plus 1 over 2. What is the sum of the constant? 1 from k equal 1 to n. So remember, when k is 1, there is no k, so it's 1. When k is 2, there is 1. So you are just adding 1 and 1 and 1 n times. So this is actually n. And then this is the sum of the square of the first natural number, which is basically, there is a formula for that, which is n times n plus 1 over times 2n plus 1 over 6. So if we plug this value back here for this sum and then simplify again and then find the limit, so after simplification this is what we are going to get: limit n goes to infinity Plug this value here, cancel the n and n, and then divide this inside thing by n. That is eventually gives us 13 over 2, 1 plus 1 over n. Here just this n times n is cancel out, so this is just 9. Here if you cancel 4 over 6, which gives us 2 over 3, and then there is an n cube and there is one n, so you can cancel n and n. For the leftover n square, you divide one of this by n and another one by n. By doing that, it will give us 1 plus 1 over n times 2 plus 1 over n. Why we're doing this? Because eventually we would like to find out the limit, and while finding the limit, if n is on the denominator, that limit goes to 0. So if you apply this limit here, this would be 0, this would be 0, this would be 0, and after limit, the leftover thing would be 13 over 2 from the first term minus 9 from here. There is no n, so the limit does not affect anything here, minus 2 over 3 times, from here it's just 1 because this second term would be 0. From here this is just 2 because the second term would be 0. So eventually this is the number we are going to get, and if we add them by making the same denominator, this is the answer we're going to get, negative 23 over 8. Let's go to the next problem. We know that integration, definite integration, if the function is positive, is it represents area under the curve. So in this case, the curve is absolute value of x, so its area, this is above the x-axis, so absolute value of x is always non-negative. So we want to find out the definite integration from -3 to +1. Basically we would like to find out the area under the curve from here to here. So this area can be divided into two parts, which is area of this part A1 and area of this part A2. So this is actually area A1 and A2. Because definite integral means, for the non-negative number, definite integral means it represents area under the curve from B to A, sorry, A to B, whatever, -3 to 1. So if you look at this picture A1, this is a triangle, right angle triangle. The area of the right angle triangle is half times base. The length of the base from -3 to 0 is 3. We're just talking about the length, we're not talking about the coordinate. Okay, base times height. So what is the height? At -3, that will give you the maximum value, which is +3. So height is 3, half times base into height for the first one. For the second one, this is again half times base, which is base means the length of the base, which is 1, and height at 1 is the maximum one, which is again 1. So this is half times 3 times 3, which is 9, and this is just half, so which is eventually 9 plus 1 over 2, which is 10 over 2, which is 5. So the area under the curve of this absolute value of x function from -3 to 1 is 5e square unit. Okay, here we would like to find out this integration by using this formula. So just plug the value of a and b in this formula. So a is 0.5 and b is 4.5. Plug this value back in this formula, so that will give us from 0.5 to 4.5 of x dx, b square, which is 4.5 whole square, over 2 minus a square, which is 0.5 whole square, over 2. So 4.5 whole square is I don't know, you can use calculator, and 4.5 minus 0.5 is 4, and then times 5 over 2, which is 10. So just use a calculator. 4.5 whole square, find out that, divided by 2, 0.5 whole square, and then divided by 2. Eventually it will give you 20 over 2, which is 10. Okay, use the maximum minimum inequality to find upper and lower bounds for the value of this integration. So remember the table, this table here we discuss. If you have a function whose maximum value and minimum value is known, then this definite integral can be bounded by the minimum value of the function times b minus a, maximum value of the function times b minus a. So we just need to find out the minimum and maximum value of this function. So this is the function 1 over 1 plus x squared, and on 0 to 1, so this function, more you put the value of x, like if the value of x is growing, this, because it's on the denominator, this value of the function will go down. Okay, so at 0 the value of the function is 1, at 1 the value of the function is half. So this is how it goes. So the maximum value is at 0, which is 1, and the minimum value is at 1, which is 1 over 2. So the maximum value of this function, maximum and minimum, so minimum value of this function times b minus a, b minus a means b minus a, and then it is less or equal to 0 to 1, 1 over 1 plus x squared dx, and this value is less or equal to maximum value of the function times b minus a. So just plug b and a, and then minimum value of the function is given here by using this graph. It's a half times b minus a, which is 1 minus 0 is 1, and then so maximum value is 1. So 1 times b minus a is 1. So this is bounded by 1 from the upper bound, and then half by from the lower bound. Okay. Okay, use a definite integral to find the area of the region between the curves y equal to 4x and then x-axis on the interval 0 to b. So there is a 0 and there is a b. B is any number which is greater than 0. And this is the function we have given y equal 4x. So this is the graph of the function. At 0, it's a 0, 0. And at b, if you put x equal to b here, the y would be 4 times b. We would like to find out the area under this curve and then x-axis. So this is the area we would like to find out. This area, there are two ways to find it out. One is finding use a definite integral to find the area of the region between the curves. So definite integral from 0 to b of 4x dx is equal to, as you can see that this is actually the area of this triangle, which is half times b times b, means it's base, which is b, times height. Height is 4 times b. So this is 2 and 2 cancel out, so it is 2b squared. So this is the area. Okay.